Lesson 4, applications of vectors. And we're going to begin with the famous river problem. Actually, no, we began with an airplane in a crosswind. On your test, which is still about 2 and a bit weeks away, on the written section, I am going to ask you an application question. It's either going to be an airplane in a crosswind or the famous river question. What does it look like? An observer is standing on the shore of a river which flows to the east. I just saw a direction, so I'm going to put a little compass rose. He sees a boat traveling across the river. The boat is pointing due north, but the current gives a resultant velocity of 8 meters per second at 65 degrees north of east. DULP. What does DULP stand for? Draw a little picture. Okay. Which way does the river flow? To the? So I'm going to draw my river like that. And I'm even going to label this little arrow with a velocity. I'm going to say this is the velocity of the current. It's going to the east. I don't know how big it is, but it's there. What they've given me in this question is the resultant velocity. Ryan, can you read me the resultant velocity magnitude? Actually, let's stop for a second. We've got to use our imagination. Don't write this next bit down. The boat is pointing straight north, but the current is pushing it that way. And so don't write that down. That's the path that we're seeing from the shore. Does that make sense? Very similar to the airplane in the crosswind. Can you read to me what the observer from the shore is actually measuring, the resultant velocity, magnitude, and direction? North of what? North of what? North of what? I'm going to start out going east first. I'm going to start drawing my picture right about there, kind of in the middle of my diagram. I'm going to go east first. What of east? How many degrees? Which is more than 45. I'm going to eyeball it. I think this looks probably about like that, where that is 8 meters per second, and this angle here is 65 degrees. Did I say angle? We're going to break this up into components. I'm going to break this up, and I'm going to redraw this triangle now because this is a bit cluttered. I did leave some room right here, so I'm going to draw this 8 like that. And I'm going to break this up into Vx and Vy, vertical and horizontal, 65 degrees. Chelsea, what's A you want me to find? Look at this vector triangle that I've drawn. One of those 3 sides is actually the velocity of the current. Which one? The 8, the Vy, or the Vx? Yeah. Ah, in this case, now if the river was flowing north-south, it would be the vertical one, but that's why I kind of drew that in. You know what? This is that. So I'm going to label my triangle that 8, opposite, adjacent, or hypotenuse, Chelsea. What about the Vx? Which trig function? I think you're right, but I couldn't hear. Cos? So if I want to find how fast the current is, it's going to be the cosine, what always goes next to the trig function, the angle, 65 degrees, is Vx over 8. I guess Vx is going to be 8 times the cosine of 65 degrees. So one question that I could give you as an application would be to give you the resultant and say, well, what must the current be? I do, though, have to give you the direction of the current so you know which vector you're going to be picking, the vertical one or the horizontal one. 8 cos 65. Do y'all get 3.380? Oh, 3.38? per second. Kenzie, what does B want me to find? Keep reading. Across the river, that's important. Which of those three vectors in my triangle is the speed of the boat traveling across the river? And I'm going to give you a hint. It's not the 8. The vertical, the Vy, that's the component. That's what's telling me how fast the boat is moving across the river. Vy, Mackenzie, opposite, adjacent, or hypotenuse? Oh, sorry. Color. There, now you're happy. I could just see some of you were missing that. Which trig function? I'd use sine. Again, I could use tangent and use my answer from Vx, but why not use the numbers that they gave me? Also, I notice this is almost identical to what I just finished doing, but instead of cos 65, it's sine 65, and that equals Vy over 8. I say to myself, haha, I can just backspace and edit. Less typing. And I get 7.25 meters per second. So the boat is traveling north at 7.25 meters per second. The current is pushing it east at 3.38 meters per second. And the person on the shore sees the boat moving kind of diagonally. And it's kind of weird because the boat is still pointing straight north. It's kind of crab walking sideways across the river, which is what happens all the time in a cross current or a cross wind. C. If the river is 256 meters wide, how long does it take to cross the river? Matt, what's this question asking me to find? Time. Now, for vectors, specifically for the airplane and the river question, you can assume that A is 0. I could, I guess, throw an actual acceleration in there too, but Oscar, that's overkill. What does it ask me to find, Matt? What's this 256?
Distance.
What kind of a distance? Look up. Patience. Look up. Go back to your diagram. Look up. Is that this distance here vertically? Or is that a horizontal distance? When it says the river is 256 meters wide, what kind of a distance is that? Where am I going to draw that? I think like that. Or I could have put it hairy in the middle, or I could have put it right there, but I think it's vertical. Yes? So I'm going to be clever. I'm going to call that dy. Just in case there's a horizontal distance later on. So Matt, down here, remember our approach that we used last year that I nicknamed DFIC, which stood for list your data, find a formula, insert crunch. And I said, hey, if I'm not sure what to do, I DULP and I DFIC. Those are my fallbacks. So I'm going to say dy is 256 meters. And I've already told you A is 0. We're not accelerating. What else do I need if I wanted to find time? Now you might need your formula sheet out, unless you remember these from last year. Speed? In this case, since A is 0, the initial velocity will also be the middle velocity, will also be the final velocity. But here's the key. Which velocity? Because this picture here has 3 of them. What letter did I put there? Because I asked you to. What letter did I put there? Y. Because the letter Y. You cannot put different directions in the same equation. That's going to be the most common mistake this unit, and I know I'll be setting you up later to tempt you to do it, Maggie. Vertical equations have to have all vertical components. Horizontal equations have to have all horizontal components. So what's going to go here is Vy because it's dy. In other words, the 7.25. And you better believe, Cole, if this was a multiple choice question, I would also have solved this using the slanty 8. And I would probably have that as answer A just to really, really tempt you. Hey, Matt, I'm looking for an equation that has a T, a D, an A, and a V in it. There is one. And it should be kind of a familiar friend when you read it. Hopefully you'll get a small smile and you, oh, I remember this one. Equals, why did you waste my time? Oh, do you need to read to me the plus a half AT squared, or is A 0? So I would have said to you last year, why did you waste my time? And you would have sheepishly said, oh yeah, I didn't need to read that. We have this. You know what? Since we're reviewing, I'll write out the whole thing. D equals VYT plus a half AY T squared, and I'll do that. Now, you don't have to if you don't want to, but if you're trying to remember why we crossed it out, it's because we're going at a constant speed. A is 0. Matt, how would I get the T by itself? Oh, hang on, sorry. dy equals VYT plus a half AY T squared. Why didn't I put a Y on time? It's a scalar, who cares? But anything that was a vector, you saw I put the Y there. It takes 1 second, but it reminds me I better make sure I put vertical components into a vertical equation, or I put horizontal components into a horizontal equation, and I almost never use the slanty ever, 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 ever. Not once I've broken it into components. Matt, how would I get the T by itself? More specific. What's the V doing to the T? Adding, subtracting, multiplying, or dividing? So I'll drop. Hello. No, that was strange. I felt like I'd gone to like some weird alternate universe where suddenly, you know, everyone's sprouting goatees and now they're the evil Captain Kirk or whatever. Okay, T is going to be dy over Vy. Cool. So it's going to end up being 256 divided by 7.25. Matt, I'm going to write 7.25, but it just so happens I have the full value stored on my calculator, so I'm going to go 256 divided by answer button, because why not? Less work, more accurate. My calculator rants don't stop even in grade 12. It is. 35.3. Yeah.
Do we just ignore the current?
It's not in the same direction, so who cares? It has no effect. That current is not affecting anything vertically. 35.3. Units, seconds. We don't ignore the current, but we only use it if that was an X, or if that was an X, because the current is an X. They're completely independent of each other. However, part D. How far down the bank will the boat have moved when it reaches the far side? Brendan, what's this asking me to find? What kind of a distance? I'm going to argue that I'm going to go straight across. If I started here, I think it wants me to find that distance, how far I drifted down, a horizontal distance. So I'm going to argue it wants me to find dx question mark. I've told you that we're not accelerating on these applications. Mr. Dueck, will we do some where there are accelerations? Yep, when we start throwing things in the air. Well, we're going to break it into components. If I throw something at an object, it's going to be traveling horizontally in a certain way. It's going to be traveling vertically in a certain way. I'll even give you a bit of the punchline. The vertical acceleration will be negative 9.8. Gravity. Oh, Brendan, I'm going to use that one. Right? Why? Because we're talking horizontal here. What was the current? Was it 3.38? No, we'll go to 3 sig figs, 3.38. Bit of a problem. I only have 2 things right now. I need 3 things to find the 4th. Time is a scalar. It can go in either equation. Oh, that's why I had to do this in this order. So I can use the 35.3 seconds. Brendan, I'm looking for an equation that has a D, a A, a V, and a T in it. There is one. It's a familiar friend. Yeah. And don't waste my time. Yeah, don't read the A expression. So dx equals vxt, and conveniently, the d is by itself already. So it's going to be 3.38 times, I wrote 35.3, but since I have 35.30809341 stored on my calculator, I'm going to use my answer button because it's more accurate and less typing, double win. 119.3, I'll go to 3 sig figs because it's my final answer. So this method will get you across the river, but you're going to have to walk back 119 meters if you want to get back to where you started from directly across the river. E. Ethan, what's the boat's engine velocity? Too slow. Ryan, what's the boat's engine velocity? Too slow. Nick, what's the boat's engine velocity? No. Too slow. What's the boat's, look at the picture, look at your triangle. Which of those velocities in that vector triangle that we solve for is the boat's motor pushing it across the river? It's not the 8. That's the combination of the motor and the current. What? What? Vy is also, and that's why I said too slow. Ethan, now tell me, what's the boat's engine velocity? You have it in front of you already. 7.25 meters per second. That component is coming from the motor. Or if it was an airplane, a jet in a crosswind, that's the jet's engine velocity. The river is the crosswind, and the resultant is what the radar sees. And yeah, the numbers are smaller, but I'm saying in terms of the physics, these are two identical questions. Airplane in a crosswind, boat going across river, same question. But now let's add one extra step. Suppose you want to end up directly across from the starting point. You don't want to have to walk back 119.3 meters. What direction should you point the boat? And what will the resultant vertical velocity be? I like this question. I like this question. I like this question. Any suggestions of how I might want to start out? And your hint is I gave you a lot of white space. Before that, I'm going to dull. Okay? I think if you leave about this much space for your work, we're going to do a small mini river over here. So I have the river like this. Which way is the river flowing? So which way am I going to have to point the boat slightly? West. So I'm going to argue that I'm going to point the boat. Don't draw this. Don't draw this. I'm going to point the boat like this. I'm just going to take a stab, and I'm going to say, I'll bet you I'm going to go like that. Draw that. And this is going to be V engine, because that's which way the motor is pointing. Now, the current is pushing that way. I want to add these two vectors together, the motor and the current. Any suggestions on how I might want to draw them? Tip to tail. So put your pencil down, look up. I'm definitely going to start to do that, but I have an advantage. I know what the resultant is supposed to look like, and the resultant this time is not the hypotenuse. I want the resultant to be pointing exactly which way. Due what? Due north. So I want you to tell me when to stop drawing the current. I can figure out the scale of this triangle because I know the direction of the current, and this right here, that's the resultant. Some of these numbers I know. How big was the current? 3.38? What was the engine? What was it, Ethan? Oh, I got it right here. That's why I asked that. 7.25? Where is theta going to go? Top left or bottom right? Where the vector is coming from. And so theta is going to go right there. That 3.38, opposite, adjacent, or hypotenuse. That 7.25, adjacent, or hypotenuse. Adjacent or hypotenuse. The 7.25. Which trig function to find the angle this time? Not tangent. This is why I said to you, it'll usually be tangent if I keep the question simple. This is a much more challenging question. Which trig function? Sine. Oh, sorry. You didn't. I just heard a very quiet, Mr. Dueck, can you color for me? Color, 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 color. So it's going to be sine theta equals opposite over adjacent. By the way, this is a nice question for airplanes, because for an airplane, typically you know what direction your resultant is supposed to be, and you'd like to know what direction do I have to point the plane in this crosswind. Do you get 27.8 degrees? 28 degrees? I'll go to 3 sig figs. 27.8 degrees. What of what? North of south, east of west? What of what? Oh, I've scrolled down. I really should have done this. North of south, east of west? What of what? Ooh, a little challenge here. Yeah, it is west of north. No, it's nice lines finish last. Of north, which way of what? That way. And yeah, that's the boat. You're right. The slanty line is the actual boat itself. B. What will the resultant vertical velocity be? Well, now I can find this either using Pythagoras or trig. You know what? I'm going to use Pythagoras because they gave me both of these values anyways. So, however, I'm not finding a hypotenuse, so I'm not going to add them this time. Then it's going to be 7.25 squared minus 3.38 squared square root 6.41. A good follow-up would also be using this method where you end up going straight across. How long will it take you to get across the river? Well, we can use this same method here, except this time Vy is not going to be 7.25. This is the Vy as well as the Vr. It's going to be 6.41. So 256 divided by... Instead of 35 point whatever, it'll take 39.9 seconds. A little longer, but you're going to save yourself a 119-meter walk. This is the way most people cross rivers. You point the boat into the current. It looks a little strange because the boat is pointing one direction and going straight up. But that's how you do it. Handy hint. If they give you a vertical distance, use a vertical velocity to find time. If they give you a horizontal distance, use a horizontal velocity to find time. Do not ever put a vertical into a horizontal. That's a sin, not a sign. Next page. This is basically the same question we just did, just to reinforce it. An observer standing on the shore of a river flows to the east. He sees the boat traveling across the river. The boat's velocity in the river is 12 meters per second, 55 degrees north of east, but the boat is pointing due north, so it's drifting kind of at an angle. Did I say angle? Components. Dulp. (12 meters per second) at 55 degrees north of east. North of what? East. North of what? East. So it's going to be north of east, and that right there is going to be the 55 degrees. I'm going to redraw the triangle a little bigger over here so I can play with it. So there's the 12. There's the horizontal component. There's the vertical component. What I should have done, just to make this question a little bit differently, is instead of having the river flowing east-west, I should have had it flowing north-south. But it's the same kind of principle. So in this case, Vx is the current and Vy is the boat motor. If I had it flowing northwest, they'd flip. Oh, and the angle is 55 degrees. How fast is the current? Hypotenuse, adjacent. Color, 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 color. Cos? Of course it is. 55 equals Vx over 12. And I get 6.88, I think. Or is that wrong? 6.88? And that's going to be meters per second. That's the current, as well as the horizontal velocity of this boat. How fast is the boat moving across the river? Well, that's Vy. And it turns out to be sine 55 equals Vy over 12. Vy ends up being 9.83. Meters per second. Pardon me? If that was an acceleration, the 9.8 would be a free fall, but it's a velocity, so we're going at a constant speed. Mr. Dueck, what if you added an acceleration? I'd have to tell you whether the acceleration was horizontal or whether it was vertical, and in our distance equations, the A wouldn't cancel, and there would be a V final. I figure that out by going VF equals VI plus AT. So all the same stuff would work, Cole. It's just way more writing, so I haven't bothered. If the river is 320 meters wide, where's that 320 meters going to go? Here, or on the other side, but I'm telling you, it's a vertical distance in this question. So I'm going to say to myself, they want me to find time. They gave me a vertical distance. A is 0. So we're also going to use a vertical velocity. Matt would point out, hey, Mr. Dueck, it's D equals VIT plus a half AT squared. Mr. Dueck would say, why did you waste my time? Matt would say, you're right, I didn't need to say the plus a half AT squared because A is 0. And so, Mr. Dueck, I'm going to end up using dy equals VYT. Mr. Dueck sticks the y's there just to remind himself, make sure I only put verticals into verticals or horizontals into horizontals. I get the t by itself. So it's going to end up being 320 divided by 9.83, although I'm going to use my answer button. 32.5539890, 32.6 is correct. Units for that are seconds. Why didn't I put a y on time? It's a scalar, but that also means it can be used in a horizontal equation. Woohoo! By the way, you're going to find when we're dealing with vectors like this, a lot of our time is going to be spent finding time. Certainly for projectiles, we're going to spend most of our time finding time because it's the one thing that can go in either equation. So once you find it, the question falls apart. How far down the bank will the boat have moved? So now they're asking for that distance there, which I'll call dx. So now they want me to find dx, which means I'm going to use vx, which was 6.88. A is still 0. Oh, and I can use time, 32.6 seconds. I think I'm going to use dx equals vx times t. Then what happened to the plus a half at squared? So it's going to be 6.88 times 32.6. Although I didn't type 32.6, I used my answer button because it's less typing and more accurate. Double win. I got 223.97, 224 meters. It's going to be a fairly hefty walk. What's the boat's engine velocity? Too slow. What's the boat's engine velocity? I already know it. In this picture, it's going to be the 9.83. Yes? By the way, really what we're saying is this. Don't write this down. On your formula sheet, you have this equation. V engine plus V wind equals V ground. Yeah, it's not annoying, are they? You know what? Here's the nice thing. What letter does wind start with? What letter does water start with? You can really treat it the same way. We're saying you add the engine and the current, and you get the ground velocity, the velocity with respect to the shore. And this has been my argument with Adam, where I've been saying this is really the same question as the airplane crosswind. Those are the two big applications. F. Suppose I want to go directly across. What direction should I point the boat? Well, if the current is going east, I'm going to point the boat a little bit west. I'm going to dulp. I think I'm going to point the boat this way. And that is going to be 9.83. It's the engine velocity. I'm going to add, and again, don't think that the hypotenuse is automatically the resultant. This time it's not. This time we're adding the hypotenuse to a leg because the current is going sideways. But I know what the resultant is supposed to look like. I want the resultant to be due north. So I can stop the current right there. I would not go like this because then the resultant would be pointing slanty. I would not draw it like this because then the resultant would be pointing slanty. I know exactly what this is supposed to look like because they want me to go directly across. If they didn't tell me that, I can't do this question. What was the current? The current was 6.88. Theta goes right there. Opposite hypotenuse. It's sine this time. It doesn't always have to be sine. It all depends on how I flipped this diagram and what information that I gave you. Could be cosine, could be tangent. In this case, it's sine. It was usually tangent in all the easier ones that I gave you, but don't try and memorize patterns that aren't there. It's going to be sine theta equals 6.88 over 9.83. Theta is going to be 44.4 degrees. North of south, east of west. What of what?
West of north.
This is west of north. Oh, or 90 minus this. 45.6 degrees north of west. That's the same vector. B, the magnitude, the resultant. I'm just going to do the Pythagoras, I think. So it's going to be 9.83 squared minus 6.88 squared. Oh, squared, Mr. Dueck. Square root of that, 7.02? Okay, I was going to say 0.1. Almost exactly 7 meters per second. I didn't ask this, but as a follow-up, I could now say, hey, how long will it take to go across the river now? And it would be that vertical distance divided by this velocity. Take a little longer, but you're not going to be having to walk back. Your homework. Let's see, am I going to give you all of these? One is good, skip 2. 3, and you're going to probably have to draw these on a separate piece of paper somewhere. 3 is good. Skip 4. 5, let's do A. And D, we'll kind of bookend it. Seven. I skipped 6. Yeah, 9. 10 is a river question. 11 is good. 12 is good. I'm going to skip 13. 14 is good. 15 is good. 16 and 17. It's a lot, but I'm trying to give you lots of time to work on it. I was hoping to give you a little more time, but lots of vector math.